order to perform buckling analysis on that particular pipe, I have opened Ansys Workbench. Now I am going to take the static structural, drag and drop it on the project schematic. And once I drag and drop it onto the project schematic, I am going to double click on the engineering data. And here by default structural steel is applied, and in the problem also this particular pipe was made up of structural steel, but the Young's modulus is 30 E3 psi. So for that purpose what I am going to do is I am going to go to the units. I am going to change the units to US customary, and once I change the units to US customary, then I am going to go to the units tab and I am going to press on this display values in the project units. So what happens, until now we have seen all the quantities in the units that we have defined, but when I change it to this particular option, what happens, the workbench is going to show all the units which are default units inside Ansys Workbench. So for example, if I have given the Young's modulus in MPa, it is going to show in MPa. But if I have selected the option to display in project units, which you can get here, this particular workbench will be showing all the values in the default project units, which is right now US customary. So now the units have changed. From here I am going to change the Young's modulus from 4.17 to 30 E6. So I am going to go to the units once again, and I need to select other US customary, which is this particular unit system. So I am going to select this unit system and I am going to change this particular Young's modulus to 30 E6 psi. And don't worry, it is not going to change the default value of the stored material inside Ansys Workbench. So you can just close the engineering data, and once you close the engineering data, you are going to right click on the geometry, say import geometry, and you can select this pipe. Then once you have selected the pipe model, you need to double click on the model cell. Then once the Ansys mechanical has opened, I need to apply the boundary conditions and loads. So what I am going to do is I am going to go to the mesh and I am going to say generate mesh. You may ask why you haven't changed this particular selection, as the default selection for this particular body will be structural steel material. I need not change the value. And once I have generated the mesh, what I am going to do is I am going to right now just right click on static structural, say insert, go to this fixed support, and I am going to select this particular face and I am going to apply the fixed support. And once I have selected this particular fixed support, I need to apply the force, and remember this particular force should be compressive force in order to decrease the stiffness of this particular structure. So I am going to right click on the static structural, say insert, go to force, and once I select the force, I need to select the face on which I need to apply the force, and I am going to select this face. I am going to press apply, and instead of vector I can change it to components, and in the components you can see here that this Z direction is in the axial direction of this particular pipe. So I am going to select the Z component, and in the Z component I am going to give the value here. So in the first case what we are going to do is we are going to apply a load of 1 pound, and then we are going to solve the buckling problem, and we are going to find out the buckling load factor. So I am going to give -1, as this load should be in the negative direction. So if I am giving it in -1, it is showing upward direction, then you can just change it to 1. Once I have changed it, now I have applied the force in the required direction, which is the downward direction. So I am going to right click and say solve, and once I solve this particular problem, I am going to check the stresses and deformations that is going to occur inside this particular body. Because we have applied a very small load, we don't have much stresses or deformations. So what I am going to do is I am going to right click, say insert, go to deformation, and I am going to go to directional deformation, and as I have applied the load in Z direction, I am going to select Z axis here, and I am also going to right click, say, then I can right click and say insert, go to the stresses, and I can select equivalent stresses, and I am going to right click and say evaluate results. So once I have evaluated this particular results, you can see the directional deformation is somewhere around 6.3 minus 7 inches, which is very small when compared to this particular length. And here the equivalent stresses are around 0.187 psi which is very less than the tensile strength of this particular material. Now in the next lecture I am going to show you how you can perform buckling analysis on this particular pipe using Ansys Workbench.